Welcome to the Master of the NEC podcast, the ultimate destination for anyone passionate about the electrical trade. Whether you're a seasoned electrician, an eager apprentice, or just someone who wants to dive deep into the world of electrical work, you've come to the right place. Join your host, Paul Abernathy, a true authority in the industry with over 38 years of trade experience, as he electrifies your mind with in-depth discussions, expert tips, and valuable insights that will keep you ahead of the curve. Each episode, Paul will illuminate the complexities of the trade, decode the National Electrical Code, and share the latest industry trends, all while empowering you to take your electrical career to the next level. So, gear up, plug in, and get ready to supercharge your knowledge, because with the Master of the NEC podcast, the power is in your hands. Now get ready. Here is your host, Paul Abernathy.
Hey, what up, everybody? Welcome to another episode of Master the NEC, the podcast where we talk about all things electrical, whether it's marketing, whether it's electrical in general, National Electrical Code, whatever the topic goes, wherever it goes. We'll talk about just about anything. If you've never listened to the podcast before, if you've stumbled on it, we do have over 1,000 episodes on various topics, whether it's just basic code changes or talking about the National Electrical Code or marketing and hiring and firing and tips and things on running your business. For folks that don't know, I've run businesses for damn near 40 years, multiple electrical contracting businesses, both in Virginia and then in Texas. And I worked as the expert and created the ECCM program back in the day for Eaton. I worked at the city of Richmond, Virginia as their engineer and head of their inspections and plan review, as well as city of Alexandria, Virginia. And of course, I worked at NEMA, the National Electrical Manufacturers Association. I was there for a couple of years as one of their technical experts for the South. So I had about 13 states, I believe, that I was kind of overseeing, and I had my hands in just about a little of everything. And then in 2014, I ended up going to work for Encore Wire, which is now Prismium, but it's the world's largest wire and cable manufacturer. And of course, all that time, I built my Electrical Code Academy and been teaching people for decades now the National Electrical Code and preparing them for electrical exams and just creating content to help people better understand the National Electrical Code. A couple of years ago, I kind of started dabbling into the social media. Have a love-hate relationship with social media, of course. People always love to hate people, especially when they're jealous of them or they just don't understand. And that's okay. I embrace everybody. They can ask anything they want. But I have a low threshold for BS. So when somebody wants to do a chest pounding session, I usually shut them down pretty quickly because that's not what I'm here for. I'm not here for the clicks. I don't really monetize much of anything. The only thing that I do monetize is my podcasts do have some type of monetization on it. And then YouTube. YouTube is what I originally started. And so that when that started, you got to some certain level and you got a little bit of monetization. It's not a whole lot. I don't promote these things. That's why I created our own network over on Fast Tracks 2, because I'm really not into those type of things or that social media thing. But I still do it like I do these podcasts, and I talk about all different types of topics. So that's where we're at today. So today we're going to talk about some topics today, some questions that you may or may not find interesting. But remember, you can always reach out to me. There's many ways that you can reach out if you do have questions or you want to get some clarification on something. I do serve on code making panel 5 and 17. I don't know how much longer I will. I'm really trying to wind down that part of my career. I'd rather me more submission. I did not submit any public inputs for the 2029 edition. I figured there was going to be, I'll leave that to everybody else. There's some things that I could have worked on, especially in tray cables and things like that. But I figured I was going to take a break from this cycle and kind of wind down. And that's kind of what I'm doing. As I move on from here, obviously I'm going to be involved in the process, but I'm going to be just like everybody else. I'm going to submit public inputs and things like that. Probably won't go to the meetings once this is all done like I used to, and that type of thing. It's all a part of eventually, winding it down. I've also, got into other ventures. Most people know that we have thermal electrician, and that is basically teaching people thermography for electrical. I have a passion in that. And I've always had multiple cameras, but I've got 4 cameras now that we utilize and for that side of the business and training that I use. EVSE is the brand that I currently have. But then also we've done TradeHog. Many of you are probably familiar with that. That's the AI model that you can ask field questions to. So we do that too. And we have a great subscriber base to that. And then, of course, we created StudyHog, which is, for anybody that's studying for an electrical exam, it's just a great helper. It randomly comes up with questions to kind of test your knowledge of the code while it answers your stuff that you may be studying. It really doesn't matter what course you're using, whether you're using, Mike Holt's stuff or somebody else's or mine or Ryan's or it doesn't really matter because that's a standalone StudyHog. It just kind of enhances your study session, if you will, especially if you have certain topics that you still don't understand what maybe a terminology means. Then it's a great resource to be able to just cut and paste it right in there, and it'll give you a very good explanation. In fact, it's kind of we made it and we control it, but it's kind of, it's a melding of multiple different artificial intelligence tools as well as things that we feed into it to help validation. So it's kind of a neat platform, but that's at tradehog.net, .com, .org. It doesn't matter. And then, of course, what else? StackCaddy. StackCaddy is one of our latest ventures, 3D printing, making products that are really geared towards the electrical industry, because that's really all we care about, is doing that. So that's kind of what we tailor towards creating things like that. So yeah, we're going to look at some questions today. But again, I want to remind you that if you do want to send something to me, all you really have to do is go to our website, fasttracksystem.com. And just like it sounds, fast and then TRAX. Okay, not TRACK. It's TRAX, fasttracksystem.com. And over there, if you look under the info tab, you'll see where it says, Let's Ask Paul. So you can ask me just about anything you want to ask on the National Electrical Code, electrical installation. You can ask me theory questions if you'd like, if that's your thing. You like theory questions. But that's a free resource, doesn't cost you a dime. So check that out. All right. So we're going to get into some questions today. I want to make sure that I answer some of these questions that have come in, and the ability to be able to answer these and give you some reliable background and code references where necessary. Oh, I want to mention too real quick before we get into these deeply. Starting in July, EC&M magazine, I'm writing for them, and I'm trying to write something that is unique. We wanted to do something that was unique that wasn't done. Mike Holt has been writing for them for nearly 4 decades, and he does an amazing job. He always has. But it's code very specific, and Ryan Jackson's going to be picking up that mantle specifically. I'm going to be doing some code stuff and some videos, but I'm also bridging that gap and trying to come up with, I was charged with coming up with a series that can appeal to electrical inspectors, engineers, design professionals, and electricians, and some of the interaction and relationships. I mean, I see on forums all the time where there's arguments back and forth. That inspector doesn't know anything. That electrician doesn't know anything. This inspector. So, there's different ways to look at certain things. So we wanted to come up with a series that kind of highlights that. So look for that to come out here in July, as well as I'm doing some videos for them and some other podcast stuff as well that'll come out. been staying very busy working for EC&M magazine. So, but anyway, let's go on and get into some topics for today. Okay, so the first question is, in the 2023 NEC, load calculations are in Article 220. In the 2026 NEC, where did they go? And does that change how we apply continuous load multipliers? Okay, well, in the 2023 branch circuits, feeders, service load calculations, they were in Article 220. And in the 2026 NEC, those same rules for load calculations, they were reorganized and they were moved to Article 120. Okay, so that's the first big thing that you start to realize when you start dabbling into the 2026 NEC. You start getting those code books, your localities start changing a little bit. And especially what makes it difficult is that if you're in the 2020 and your state jumps to the 2026, or if you're in the 2020 and you go to the 2023, but when codes are changing, you get so much noise about the code changes, right? And so you'll hear so much about 2026 that you'll forget that your state is really not in the 2026, right? That they're in the 2023. And so, but you hear so much noise and then it's kind of like your brain skips over the fact that you're not on the 2026, you're on the 2023. So it can get really confusing for a lot of people, especially because around every code cycle, your state could be changing from 2020 to 2023, but maybe it's happening right at a code change cycle. And it gets confusing because you may not be on 2026, but you're hearing all this flutter about it, and then it kind of gets a little muddy for everybody. So I encourage people to, keep that in mind. The big difference that we're dealing with is 2026 makes it clear that load calculations themselves are not automatically required to include 125% multiplier for continuous loads. Okay, that does not mean continuous load rules are disappearing. What it means is that the 125% factor is generally applied when sizing branch circuit conductors, feeder conductors, and overcurrent devices under the rules such as 210.19a1, 210.20a, 215.2a1, and 215.3, unless a listed 100% rated assembly or specific rule changes that result. So it's been made clearer to folks that when you're doing load calculations, you're typically not going to be bound by the 125%. But when you're doing the branch circuit calc, feeder calc, and overcurrent device calc, you do take those things into consideration. So calculation, when you calculate the load first, then apply conductors and overcurrent sizing rules where the NEC requires them. Don't blindly add 125% to every continuous load inside of the load calculation unless the specific rule requires it. So again, we were doing a service load calculation and people are doing the calculations and they forget that we may have done that, for example, for a water heater when we size the branch circuit to it. And we did that sizing the conductors, right, in 422. We did all that, but that doesn't carry over to the service load calculation. We don't go, oh, by the way, we have to take whatever the load was for the water heater and treat that as a continuous load. You get what I'm saying? So we don't do that. So the 2026 made it a little clear, do your calculation, but you may need to apply the 125% for continuous loading to other things like the branch circuit or the feeder application, not necessarily carte blanche to the actual load calculation of the structure itself. Does that make sense? So again, in the 2026, all of this gets changed to Article 120. So a lot of the nomenclatures get changed and everything gets moved around and everything. But the 2026 key summary is basically identifies as 120.5E as changing how continuous loads are addressed in load calculations. So if I have to give a takeaway to anybody, jumping into the 2026, I mean, you're taught all the time to take continuous loads at 125%. And this is grilled into us. But I would say take a little time and read 120.5e and see how this has changed a little bit and how you're going to consume it when it comes to the overall, like a load calculation for the structure. Okay. Because it's not intended to immediately do that unless the code says do it. Okay. You still do that for the branch circuit sizing, feeder sizing, if you have continuous loads, but it doesn't automatically translate into the service load calculation doing that. Okay. So I encourage you to read that 120.5e. So it's a great time to pause the podcast, go grab your code book and read it. Okay. That was a good question. A lot of people ask that question because, you're familiar with seeing the reference to continuous load everywhere, but you don't think about the fact that, that doesn't necessarily have to equate to the actual overall calculation. And so the code actually says percent multiplier. It says load calculation shall not require continuous loads to be calculated at 125%. That's for the load calculation. Again, remember, and there's an informational note there, by the way, so that those that are, that grab their 2026 and go look at it, there is an informational note there. And it still reminds that you still may have these continuous loads in play with the 125% multiplier for other reasons, like sizing of conductors and overcurrent protective devices and all that kind of stuff. So just there's diversity in an actual load calculation. So this just brings clarity to the intent of the code. All right. So that's one I'd say go, get a look at. And of course, as always, if there's anything about that you still question, be sure to let us know in the comments or wherever you're listening to this podcast, or feel free to reach out. I'm more than happy to go in even more detail if necessary. The next question that somebody has sent to me, it says, Paul, when calculating a dwelling or non-dwelling service or feeder, can we omit the air conditioning load when the heat is larger, or omit the heat when the air conditioner is larger? Okay. So this has a lot to do with the non-coincident loading. And we use AC versus heat because that's an easy one, right? Because it's either the heat's on or the AC's on, one or the other. They're not on at the same time. Now, if there is a situation, heat pump, whatever you have, that both would be on at the same time, then they're not considered non-coincident loads. And you have to account for all loads. So that would still be added into your load calculation. You just may not get any breakout. You just take the full value, right? But there is a rule in the code where it talks about the non-coincident loads. And so it's one of those things that, the answer is yes, but only when the loads are truly non-coincident loads, meaning they are not expected or permitted, to operate at the same time. So the code gives you two parameters for this, especially in the 2026 edition. It says, okay, if it's unlikely that they'll operate at the same time, and that unlikely could be due to something have to do with a timer, or something to do with an interlock, or something that makes it unlikely for this to happen. And of course, AHJ is going to have to, understand what's going on. So you just you got to explain it to them. Or you could have something under listed equipment that is mechanically designed to keep them from operating simultaneous. Either way, those would be situations of a non-coincident load. Now, in the 2023, this is handled in 220.60. Okay, so a non-coincident load, that's what it's titled. The basic concept that there are two or more loads that will not operate simultaneously. That's at the same time. You are permitted to only use the larger of the two loads that would be running at any one given time. Now, however, the common mistake is skipping the fact that there is a motor rule in 220.50. And people always hear us talk about, well, you got to get that extra 25%, and they go hunting for that and wonder where the hell that is. You can't forget that 220.50, it just so happens that we were doing load calculations for AC versus heat. The largest motor typically in the dwelling is going to be the air conditioning compressor, and it is a motor. And you would take that at 125% plus the sum of all the other loads that would be running under air conditioning, and then compare them to the heat. And if the heat was greater, then you just would get rid of all of the AC's loads because you're going to size the load based on the larger of the two, because that's what the non-coincident load rule allows. But then, of course, when it comes to the motor, you still have to account for the largest motor. So now, since the AC is gone and you've removed all that because the heat was larger and we're sizing for the heat, so it doesn't matter. This is where people get lost. And I don't know how to dumb it down simpler than, look, if I size conductors and I size loading and I do the calculation for the larger of two loads, it doesn't matter if the lesser's running. As long as everything is sized to the larger, what does it matter? If everything's sized to 100 amps, but the lesser's 60 amps, why can't I just forget about the lesser if everything's sized to the larger? Absolutely. And that's the concept here. But it has to truly be a non-coincident load. Now, you still have to account for 220.50. It just so happens if the AC was larger than the heat, and we already did the AC motor at 125%, then we already have accounted for 220.50. It's already been figured in. We don't have to do it again. But if the heat is larger than the AC, and the AC is removed from the equation, that's gone now. So you now have to go find the next largest motor-operated equipment that's in the structure. And that becomes the one where you're going to gain that 25 additional, because you probably already took that motor at 100% when you did maybe an appliance calculation or something. You've probably already done it. So all you're doing is looking for that extra 25%. Now, so many people out there want that to be in the code. They find this very confusing. It's not confusing. If you go to 430.24, obviously when this is being applied, it's because you have multiple motors in the building. So if you didn't go and spend all that time in the non-coincident loads and you just have multiple motors in a building, then you know that the rule in 430.24 for motors is you take the largest motor at 125% and the sum of the other motors. Well, that's all we're doing here. Whether the largest motor was already into the calculation because it was the part of the AC and it's accounted for, or that was discounted because the heat was larger, you still have to account for the largest motor. So that means we hunt for the next largest one. I'm not sure why this is so complicated for people to grasp. And I think it's because they want the code to be just say it, right? Just say they would like to just say it. It does say it. It just does it in its own way, right? So in the 2026, this concept has been relocated into Article 120. The key, it's still the same key, identifies the actual application. The only difference is now we have a 120.6 that talks about what's considered a non-coincident load, and it's going to make reference to 120.11a, which is going to be giving us some guidance on these loads. That's it. So it's no real change here, nothing to get worried about with that. It's just a concept, and again, surprising how so many people don't understand when we are teaching the code and we say you need that the largest motor at 25%, and all we're trying to do is capture that intent of the rule, which was 220.50, and it's obviously changed for the 2026 edition, but that's all we were trying to do. That's it. Nothing extra, nothing crazy outside of that. Still, it's 120.50 now, so it just moved from 220.50 to 120.50. So, but that's all we're trying to do with it now. That's it. Okay, what's next question we have? Great questions today. Let's see here. Paul, on a non-dwelling load calculation, non-dwelling, is if there are 4 air conditioning units that can all run at the same time, do we take one compressor at 125% and the other 3 at 100%? Okay. It's asking about a load calc, I guess. Yeah. So a non-dwelling load calc. So generally, yes, if all 4 units can operate simultaneously and the load calculation is being performed under a motor load calculation rule, then yes, generally you just do the largest at 125%, and then of course the sum of the other three, right? That is motor load calculation rules. Now, under the 2023 NEC 220.50, sends motor loads to the motor rules. For multiple motors, you would be at 430.24, which requires this. Basically says conductors supplying servo motors to have an ampacity of not less than 125% of the largest motor plus the sum of the full load current. That is full load current, not nameplate current, full load current from 430.248, 249, 250, depending on what what motors you're dealing with, single phase, three phase, or whatnot. Okay. So that's where it's there. Now, they are not non-coincident with each other. Okay, so the 125% treatment comes from the motor calculation rules, not from the non-coincident load rules. Okay, so if they can all run together, then they're coincident, right? So they could all run together. So don't use 220.60 or 120.6 or anything like that to drop three of them. No, that's not how it works. Use the motor rules. And that is the largest at 125 plus the sum of the others at 100%. That's the proper course of action. Okay. So, and those are the motor rules, and that hasn't changed. So while things move around a little bit in the code, if I have four air conditioning units with compressors, their motor loads, again, you're going to follow the same rules. Okay. And incidentally, in the 2026 edition in 120.50, it's going to be B, which is air conditioning equipment, which is basically going to send you Article 440, Part 4. Same concept. Okay, but these are motor loads, so we're going to treat them as such. Okay. Let's see here. What's another? That's a good question. They're all good questions, really. They've all been pretty good questions today. Next one says, is an EVSE treated as a continuous load? And does that mean the service load calculation must automatically use 125% of the EV charger rating? Okay. Well, EV charging equipment is generally treated as a continuous load for conductors and overcurrent sizing. We follow all that in the 2023 edition. That is in 625.42. Okay. So for EVSE load requirements, and of course 210.19A1, 210.20A, 215.2A1, and 215.3. By the way, these are feeders and branch circuit calculations for continuous loads, as well as overcurrent protection. It says for continuous loads sizing, those are the code reference you're gonna want to go to. Now, the branch circuit or feeder conductors and overcurrent protection may need to be sized at 125% of the continuous load. But for a service or feeder load calculation, and we kind of started with this, the 2026 has made it clear that continuous loads are not automatically multiplied by 125% inside the load calculation, okay, unless specifically mentioned in the calculation rules that require it. So this becomes a great discussion that many people are going to have as we move into the 2026, because people may be mixing these together, right? They may be saying, so what is the calculated load? And what size conductors are required? And what size overcurrent protection is required? These are related, but they're not always the same step. So the load calculation is different, and it's not going to account for the continuous loading when it comes to the EVSE. But the branch circuits and the feeders and the overcurrent protection and sizing of the conductors will. Does that make sense? Hopefully that makes sense. So, 2026 EV power transfer systems, they're still shown in the code as continuous loads when it comes to sizing, right? But it does not mean that you're going to change the load calculation, if you will, okay? But speaking of which, 120.57 of the 2026 NEC talks about EVSE loading, and it says for each EVSE served, Okay. So again, that's if you have EVSE. I do. My house, I have a Tesla. People know that. They know I bought one of those. Talk about that in another episode, why I did that. Not because I'm a big Elon fan, not because I just, believe that it's the amazing technology. You've heard my position on EV, the grid struggles. But my area where I'm at, it made the most sense. And I can explain that in another podcast. I don't want to get into that. But if you're expected to serve an EVSE, the load shall be calculated by the nameplate rating of the equipment, if available. And if it's not available, then it would be 7,200 watts or 7,200 VA if the nameplate is not available. Okay. So you really want to go to the nameplate. And if that's not available, you use 7,200 watts as your base part of your load calculation. You're not taking continuous loading. You're just taking it and add it to the load calculation. Okay. That's the whole point of when the code went out of its way to say, you don't always take continuous loads in the overall load calculation at 125%. No. You may for the conductor sizing, you may for the feeder, you may for the branch circuits, you may for the overcurrent protection, but not for the overall load due to diversity. Okay. So again, just makes it real clear. Now, if your nameplate's greater than 7,200, obviously you folks know you're going to use whatever's greater. Okay. I'm just saying. Good question, though. That's another good question that people have been asking lately about EV. So what's next? Let's see. Let's see here. In the 2026 NEC, what is the difference between Article 624 and Article 625, and which one applies to, let's say, a Tesla wall charger? Okay, so I did a podcast on this already. I would assume this person that submitted this probably did not listen to that episode. It's a great example of going back and listening. Now, all of our podcasts now are also on our YouTube channel. They are podcasts, but they are also available for you to listen to over on our channel. So again, we did that for a while and we stopped, but we're back to doing that. So they're up there because a lot of people sent in and said, look, I like listening to the podcast on the simple YouTube, and that's fine. So we did that. Okay. So let's just, Tesla just happened to be what I have. I have a Model Y Juniper, 2026. So in the 2026 NEC, Article 625 remains the main article for electric vehicle power transfer systems, like electric vehicles, okay, on the road type of vehicles, okay. Whereas the new 624 covers electric self-propelled vehicle power transfer systems. That would be things like agricultural, marine type of EVs, self-propelled electric, like golf carts, or those you see those trailer park type carts, things like that, or people that go to the beach, those non-gas electric golf carts and things. So charging those type of things now have some rules that before were a little muddy in how you do them. I know at Encore Wire we have a bunch of these really nice. They look like little golf carts, but they're like tricked out. I mean, they're just amazing looking. They're pretty cool. They're long. They hold a bunch of people, but they're pretty cool. They take people on tours, but they're all electric charging. And so we really lacked a lot of rules for that. But 625, just remember, if you're dealing with EV vehicles, Teslas, Rivians, Chevrolet Volt, the Bolt, Rivian, all that kind of stuff, Ford Lightning, whatever it is, you're going to be in 625. If you're doing something for carts and golf carts and all that kind of stuff, then you're going to be in 624. Okay, and they mirror each other very well. In fact, it's a classic case of where they probably cut and paste a vast majority of 625 over into 624 and just take out what's not real relevant to the self-propelled versus the regular EV. But that's what they did. Does that make sense? Okay. Next question we have, it says, if conductors or wiring methods are damaged by water, fire, overheat, corrosion, or similar conditions, can they be reconditioned and reused under the 2026 NEC? No, so under those conditions, somebody's going to have to make the determination. If it's obvious that something was overheated or corrosion or been subject to submersion, or wet locations that have been subject, maybe dry location product that's been subjected to wet location, this is going to be an AHJ's call. However, now in the 2026 edition, we do have some teeth for that for the AHJ and the manufacturers. 300.4c was introduced in the 2026, and it deals with damaged wiring methods and conductors. So the practical answer is that damaged conductors and wiring methods must be replaced. It's not just as simple as, Johnny, go out and grab the electrical tape. Also, for additional guidance, they added the 2 references to the NEMA documents that are available, evaluating water damage as well as evaluating fire damage. These are documents that are put together collectively by all the manufacturers. And so they give recommendations from a manufacturer. Of course, there's a case-by-case situation. And this is not the same as reconditioned. Okay, totally different thing. It's in this situation, it's important now that this is a major field issue when you've got flooding, fires, overheating, raceways, failed terminations, corrosion, and inspectors come and look at it, mechanical damage. Equipment may sometimes have reconditioning rules somewhere else in the code for certain types of equipment. Like, for example, the standard circuit breakers, there is no recondition. GFCI devices, there is no recondition. AFCI devices, there is no recondition. That's just a full flat-out replacement. Okay? And in a lot of the manufacturers, for example, of wire and cable, if non-metallic sheath cable is submerged or water gets into the end of it, it's a flat replacement. Okay, because we don't test it for long-term exposure to moisture that would be up into the paper jute that gets up into the cable assembly and what it can do long-term, right? We have no history of that. So, it's something that should be replaced. And that's typically the guidance you're going to get from the manufacturer. But generally, you cannot recondition damaged conductor insulation. Once it's gone, it's gone. And in the past, people would say, I'll just throw some electrical tape on it. But the fact of the matter is, you can't put insulation back on a conductor. Only a manufacturer can extrude insulation onto a product. And then it gets evaluated by UL to make sure it meets the proper UL 83, UL 44, testing in UL 2556, all these different standards, so that when it's being utilized and it goes from being compliant to not compliant, I mean, it's still listed, right? Because it's already left the factory. It's in the field. The problem is when it gets degraded to the point where it's exposing conductive material because it's been damaged, you can't really just wrap it with electrical tape. And I know that's not what people want to hear. And that was in the past, that's what people would do, right? So if a conductor's insulation has been cooked, soaked, chemically attacked, physically damaged in some way, code answer is now clear under 300.4c is the answer is not wipe it off and megger it, right? That is not the answer. The 2026 NEC now gives inspectors clearer language to require a replacement, okay? So, and this was driven by the Steel Tube Institute, again, different wiring methods exposed to conditions that are outside the scope of their listing. And there is no real way of knowing how they're going to react long term. It's just much safer to replace it. And so that's kind of the direction that it was going. Hopefully that answers that question for the gentleman that asked that question. Well, let's see here. Do we have another one? Yes, Jeff is. Yeah, okay. Next one says, if EMT, PVC, or another raceway is installed outdoors or in a wet location, the conductor is inside considered to be in a wet location. Yes, so we've been preaching this one forever. In a raceway that's outdoors, whether it's above grade or below, if it is outdoors and the raceway is physically in a wet location, as defined in Article 100 of the NEC, then it is a wet location, not only outside of that wiring method, but inside of that wiring method, okay? So that's a wiring method. So yes, the inside of a raceway installed in a wet location is considered a wet location. And that means that the conductors or cables that happen to be installed in that specific raceway must be suitable for the wet location. Whether they could outlast you or me, whether you could put non-metallic sheath cable in a raceway outdoors, underground, with moisture and you know is going to get in it. Will it outlive you and me? Maybe. Is it allowed? Absolutely not. Another example would be THHN by itself is not a wet location rated product. T for thermoplastic, 2 H's for high heat, N for nylon. There is no W in there. This is a dry location product that is acceptable in a damp location. Okay, believe it or not, go look that up. Now, but most modern building wire today is never going to be just a THHN. It's going to be THWN-2 as well. Of course, the W is going to denote a wet location. Okay, so in the 2023, this concept appears in 300.5b, where it tells us that in underground installations, that it's a wet location. Also tells us in 300.9 that for raceways in a wet location above grade. So in the 2026, the wet location raceway rule is reorganized and expanded, and it includes now drainage requirements for above ground raceways in wet locations. Now, this could be draining it to a box with weep holes. This could be draining to a specific fitting that allows the weeping. This could be installing it in an arrangement to drain to some location where it can drain. So these are important considerations now when everybody wants to do raceways outdoors, is how are they going to be arranged to drain now above grade in wet locations? Because now the new language says that it has to include drainage requirements. So the raceway does not magically keep the inside dry, right? If the raceway is in a wet location, the conductors inside must be wet location rated conductors. There will get moisture in there. It don't care whether you think it's liquid tight. It's not liquid tight. It's going to get moisture in there, okay? So no matter where it's located, you're going to need to have wet location rated conductors in there, okay? Let's see here. Another question. Paul, if I run EMT for part of a raceway system and then I change to rigid metal conduit, can I have 360 degrees of bends in the EMT and then another 360 degrees worth of bends in the rigid before installing a pull box? The answer is no. It was never intended that way because it says from pull point to pull point. But what people were doing is they were arguing that you could go 360 degrees worth of bends in EMT and then change over with a changeover transition fitting, which wasn't a pull box, and then change over to, let's say, rigid, okay, or PVC, whatever it was. And then you were allowed to go up to another 360 degree worth of bends in that wiring method. All right, so no, that is not what the intent was. But as always, every couple of years, we change the code to, people can argue the gray areas all they want, but a lot of times I tell jurisdictions and AHJs, be forward thinking. Don't be afraid to look at even if you're not on the 2026 in your jurisdiction, and let's say you're even on the 2020, it never hurts to look forward and see if there's something that seems ambiguous today. Did it get cleared up in the next issue? Or possibly the issue after that, depending on how far your state is behind or whatnot. So historically, the 360 degree bend rule appeared in the individual raceway articles, okay, such as 358.26 for EMT. Okay, so .26 was that bend rule where you don't exceed 360 degrees, and it was very common. For example, in even rigid metal conduit, it was 344.26. Okay, now. There are folks out there that would argue that if you change raceway types, the bend count could reset. Now, I never understood this argument because being somebody that's pulled plenty of conductors in raceways, working for a manufacturer and understanding what sidewall pressure is and how hard it is to pull, it's hard enough to get it through 360 worth of bends between pull points. But now incorporate that into that and start thinking, well, I can go up to 720 degrees worth of bends. That's just not practical. You're going to damage the conductors. And it just wasn't a good argument. And it's never been a good interpretation. It's, because clearly if the dot 26 is within that wiring method, it's germane to that wiring method. But the way it was written, people could argue that, right? So now that is changed. Okay. So to clarify, because some tried to argue that, again, if you change the raceway types, the bend count could reset. That was never a good practical interpretation. But the 2026 NEC closes that door completely with the addition of 300.24, which so now, instead of being embedded just in each of the specific articles for certain types of wiring methods, it is now generically placed in 300.24, and it addresses the total number of bends in combinations of conduit or tubing wiring methods. Okay, so the change from EMT to rigid does not give you a fresh 360 degrees at that transition. Okay, it's between pull points. So the Raceway system is still the Raceway system. The conductors don't care that the Raceway's name changed halfway through the run. So the common denominator here is the conductors that are being pulled for these wiring methods. So if we're the whole rule here was to try to limit the damage. And there's some wise guys out there, and I've seen them on these Facebook groups who want to talk smack about it and say, this is what the code is. But then in their same interpretation, they don't even understand what an outlet is. So you can't really, you really can't listen to them, because they clearly, they don't have a track record of being very accurate on anything. So that was never the intent. And as a real electrician will tell you, there's no way I'm trying to pull conductors through 720 degrees worth of bends. I'm not. Now, the argument would come when people would try to get a little bit more than 360, and they would argue this, that nothing says, and they were trying to, because they didn't want to redo the installation. And they were trying to convince the inspectors and yada, yada, yada. But again, that's cleaned up now in the 2026. And it just goes to show you that the intent was never dictated by the wiring method. Its basic common denominator was the conductor and the potential for damage. Okay. So whether it goes through, and this is the same argument I'll make to people who will put in a pull box. Okay. And just to meet the 360 degree bends between pull points, they will put a pull box in there and they will not size it properly because they never intended to use it. If you never intended to use it, then it is still one solid pull. It's not considered a pull point. If it's not sized properly, it doesn't meet the rules for sizing, depending on the size with 314.28, whatnot. If it doesn't meet the sizing requirement, the 6 times and 8 times and all this, then it is not a pull point. So if you're just pulling straight through it, to me, it's just another raceway. And the 360 degree between pull points is still in effect, regardless of the wiring method or an undersized or improperly sized box. So a lot of engineers, they'll just throw a box in there and say, we met the rule. The question is that box compliant in size that it's supposed to be? If the answer is yes, then you're choosing not to use it. That's fine. It's still a pull point. You're just choosing not to use it. But if that box is not sized properly and you're just pulling through it and you're just putting it in there to appease the code, to me, this even gives it now more teeth to say, nope, I'm sorry. I consider that box nothing more than a transition at this point, potentially, because we're worried more about the concern of the conductors. Now, if you don't like that, you don't agree with that, then that's where I tell you to get involved in the code. Every 3 years, we change this code. And, feel free to put in a public input. Feel free to disagree. But we're using a little common sense on this one. It's about not damaging the conductors. Okay? Okay. Let's see. What do we got next? We got time for another one? Let me look over. Jeff says yes. Okay. All right. So the next one says, does every ground screw in electrical installation have to be green? Wow. This is a great one. Okay. Jeff, I think that's why Jeff wanted me to keep going. This is a great one because there is a massive misunderstanding about the green finish on a color on a screw. Okay. So the answer is no, and we could stop there. But this is one of those areas where electricians often mix up different rules. For example, a metal box. So an equipment grounded conductor connection is covered in 250-148C to a metal box, okay? We're all familiar with that. The screw used for grounding the box must be used for no other purpose and must be identified for grounding. Means that it's basically, doesn't mean it has to be green, but it has to go in an area that specifically maybe it's raised or it's been dedicated for a specific purpose of grounding and bonding application. The NEC does not simply say that every box grounding screw must be green in all cases. Okay, now, for the wiring devices such as receptacles and switches, 250.126 requires that the grounding terminal screw to be green, hexagonal, or otherwise properly identified as specific for that rule, right? So that's an example on a device where if it's going to be for grounding, equipment grounding, then it would be green, hexagonal, or otherwise properly identified with a G or some maybe ground symbol or whatnot. Now, that's a key to remember. Now, main bonding jumpers. The main bonding jumper is the conductor or the screw or the bar or whatever that's going to connect the grounded conductor or the neutral to the enclosure. Okay, at the service equipment. So that is a main bonding jumper. It intimately connects all that together. Okay, and that is under 250.28. Now, 250.28b says that if it happens to be a screw, it doesn't have to be a screw. It could be a conductor, but of course if it's a conductor, you got to size it properly, right? So then you got to get into the sizing rules, 250.28, and then of course that's going to send you to 250.102. But if it comes with a screw, then that screw has to have a green finish that is visible once it's installed. Okay? So those, to be honest with you, those are the rules that really pertain around it. So, I mean, we might buy those green screws. They go in the metal boxes, and they don't have to be green. But if it's a threaded entry and a 2 full connections and 250.8 and it just so happens they make them green, and that makes it easy to identify. But at the end of the day, if it's a specific area in the box, it's designed for that screw. It's not going to be the other ones that for mounting. Obviously, it's designed, it's threaded for this purpose. Then that's all the intent that it needs. It wouldn't have to be green. You want it to be green? That's fine. Now, when it comes to devices and switches where they do have an equipment ground, they're going to be green. Okay. When it comes to the main bonding jumper, if you're going to be using the screw type, which comes in most panels today, most 200 amp panels, most 125s, whatever it is, when it comes to electrical panel, that is service rated panel, then it's going to have a screw. Now, some of them have these little Z bars, these zinc coated bars and things like that. But when we're talking screw, it has to be green. The Z-bar doesn't have to be green. The screw would have to be green if it was being used as the main bonding jumper. And then there's no sizing involved, right? You don't have to do any calculation. The screw comes with the equipment. That's it. Done. Right? Okay. I hope that makes sense. Okay. Let's see here. Do we have time for one more? I should mention the box grounding screw, a device grounding screw, and a main bonding jumper screw are not the same rule. So let's stop getting those grounding and bonding, all that stuff confused. Don't take the green screw requirement for one section and force this into another section of the NEC where it doesn't make reference to it just because you don't know. Right? So that was my key takeaway. I forgot to mention my key takeaway. That's the key takeaway. Don't just randomly apply different areas of the code just because it meets a narrative. It's not how it works. Okay. Let's see. Let's look at the last one here. I think it's the last one. Jeff, is this the last? No, he's got a couple more, but I don't think we're going to go more than an hour on this podcast. I start losing interest from people if I go more than an hour. Hell, some of you I've lost interest 10 minutes into it. All right. It says, what's this guy say? Hey, Paul, love your podcast. Got a question for you. When feeding a detached garage or another building from a dwelling service, can the grounded conductor and equipment grounded conductor be bonded together? Again, in the detached building panel. Generally, no. Okay, so that's that separation on a remote distribution panel. So once you're on the load side of the service disconnect, the grounded conductor and equipment grounded conductor must remain separated. Okay, now for feeders to a separate building or separate structure, 250.32b requires an equipment grounded conductor to be run with the supply conductors. Okay, so you're going to have those 4 conductors run. So the grounded conductor is isolated from the equipment grounded conductor and the metal enclosure at that separate structure. Okay, so it's basically floating. Okay, so the neutral to ground bond normally occurs at the service disconnecting means, not again downstream at the feeder panel. Okay, now there was some allowances in the code we call existing rules. It's the old 3-wire feeder allowance. That's no longer allowed for new installation. That was an existing installation based on legacy condition. But for new work, the answer is you got to run 4 wires for that feeder. You have an ungrounded conductors, 2 of them. You have a grounded conductor if it's needed. And then, of course, you have equipment grounded conductors. Okay, typically what you're going to run. Another misconception out there to folks is when it goes to feeder panels or to equipment, they think you always have to run a neutral. You do not. Now, obviously, with the remote distribution panel, you would because you're going to have 120-volt loads and you need a neutral. Okay, so no brainer. But you could have a situation whether you're running a branch circuit to a piece of equipment or something else where you're going to absolutely have no neutral loads. So where you're required to bring the neutral, or in this case, we'll say grounded conductor to the service in all applications, you may not need the neutral downstream if there is no need for neutral. You're always going to have the need for the equipment ground because you got to clear the overcurrent devices, right? You got to create an effective ground fault current path. But there may not be a need for a neutral downstream. With that said, most, germane to this question, most detached structures are going to have 240-volt loads, 120-volt loads, and so you would need to have a neutral. Okay, so just to kind of make sure that's clear. But we did at one time had an allowance that if you had no metal conductive path between the structures, then you could run 3 conductors over to it and basically treat it like a service, okay, if you will. So that changed many years ago. So that in new construction, none of that's going to take place. So you would bond at the service, you separate downstream. The detached garage panel supplied by the feeder is not another service. It's just a feeder going to another panel located downstream of the service. Does it make sense? Okay. Do I have time for one more? Yeah, let's do one more. I know I'm running close to the hour, but let's go on and answer one more. It says, hey, Paul, if the terminals are rated 75 degrees C, why do electricians keep talking about using the 90 degrees C column for THHN, THWN-2 conductors? Well, the reason for that is on a rare occasion, you could get lugs that are rated 90. If the insulation on the conductor is rated 90, and then whatever the load terminals are rated 90, then you could use the ampacity values at 90. But in the real world, that really doesn't happen too often. So usually, you're going to be limited, okay, under the termination rules in 110.14c. But when we use 90, so the code will say to us that, you know what, when it comes to adjustment and correction for conditions of use, maybe I have an ambient temperature that is other than 30 degrees Celsius, 86 degrees Fahrenheit, or I have more than 3 current carrying conductors bundled, then I have to do something to the ampacity. Obviously, it's going to be less than what we started out with, okay? Because the bundling of conductors more than 3 current, that's going to create heat. Heat's hard to dissipate. So we have to adjust the ampacity of the conductor so that the temperature doesn't get high enough that it causes a problem with the insulation, which is based on the 30 degrees C's, 86 degrees Fahrenheit. So anything that's going to cause the temperature to get above that starts pushing it closer to that volatile temperature level of the insulation. okay, which would be, again, 90 degrees C insulation. So if you take the ambient temperature and you take the heat from current flow and you don't adjust it in some way or correct it in some way, depending on your condition of use, then you run the risk of the insulation breaking down. So in order to keep that from happening, we have to do some type of calculation. And we call that conditions of use. We call it ambient temperature correction. And then we call it a adjustment for more than 3 current carrying conductors. And those rules are all in 310.15. And so it's really important. That's one of the areas that I tell people all the time. And over on our message board, NECchat.com, I actually have a free course over there that teaches ampacity. So if you're somebody out there listening to this and you're like, dude, I'd like to wrap my head around this adjustment and correction thing and understanding conductors and their ampacity, whatever the end result would be based on a condition of use, go take that lesson. It's free. It doesn't cost you anything. It's over on NECchat.com, NECchat.com. Go check it out. It's free. So let's talk about this. It's a multiple step process for conductors with 90 degrees C insulation, such as THHN, THWN-2. And by the way, THWN in itself is not 90 degree rated insulation in a wet location. That would be 75 because it does have one H. But because it has a -2 on it, it's basically treats it as 90 degree rated insulation, whether it's wet or dry. Whereas THHN has 2 H's, so it's inherently 90 degrees dry. Okay. So again, that -2 just signifies that, oh, it's okay. You can use the 90 column to do your adjustment and corrections from. That's perfectly fine. Okay. So the ampacity tables are in 310.16. That's the value we're going to use from the 90. And we're generally going to be starting point that value at 90, and we're going to apply the adjustment or correction factors where necessary in order to reduce the actual ampacity capability of that conductor based on what? The condition of use. Okay. Now, but after the adjustment or corrections have been applied, that final selected ampacity still can't exceed the temperature limitations of the terminals under 110.14c. So whatever you start out with at 90, and now you apply these multipliers to it, this is the new ampacity of that conductor. So now you have to correlate that with the selection. And that's going to also tell you whether or not you're going to be in the 75 degree column or the 60 degree column after you've done this adjustment or correction. And that's when you need to go look at 110.14c. So for most equipment rated 100 amperes or less and using conductors 1 gauge or smaller, that usually means that you're going to be under the 60 degree C column. The only exception to that is if the equipment is listed otherwise. In other words, the conductors are rated for more than 60, the terminals are rated more than 60, maybe 75, and then the loads terminals are rated 75. Well, if that's the case, then you can ignore the 60 and use the 75. If any of those things are unknown, then you stay locked into the 60. So, for example, it doesn't matter that my conductors are rated 90 if my breaker was rated 75. But the load at the end, I can't tell what the load rating is, temperature rating on those terminals at the equipment. I just don't know what they are. Then guess what? That's the weakest link. That means that the ampacity can't exceed that of the 60 degree column, even though you're saying, but wait a minute, Paul, it's a 90 degree rated conductor. It's got a higher ampacity and the lugs are rated 75. It doesn't matter because we don't know what's at the other end. And that's a limiting factor, right? Now, for equipment that's rated over 100 amperes or conductors that are larger than 1, okay, so when those that are larger than 1, say 1 and larger, then the 75 degree column is the commonly used application for the terminals. So it's very rare that we're going to have terminals that are rated 90, okay? But just remember that the 90 degree C column helps us when it comes to derating. It's our friend. Engineers all the time, I'm like, let's embrace this 90 for adjustment and corrective purposes. It usually does not let you terminate the conductors as if the equipment terminal is rated 90, unless, of course, everything's rated 90. And that's a rarity. They're out there, but it is very rare that you're going to see 90-degree rated lugs, 90-degree rated insulation. That's not rare. Most of our insulation today most of it's going to be 90. But then the load, it's going to be not 90. It's probably going to be 75 or whatnot. So those are the kind of things that you really have to stop. And this can be really confusing for people. And it's probably one of the more challenging rules that people don't understand is conductor sizing, things like that. Okay. All right. That's enough for this episode. I've gone on over an hour. I just want to make sure that I covered some of these questions. I have a bunch more people are asking. So I'm probably going to do another episode of this at some point and pick up these other questions. Remember, you can ask me any question you want on any topic. I'm more than happy to elaborate. Just go to our website, fasttracksystem.com. Under the info tab, you'll see the tab that says Let's Ask Paul. Just submit your information, be as detailed as possible. Submit it, and I'm more than happy to answer your questions on an upcoming episode or podcast. More than happy to dig into just about anything, give you the insight, any wisdom I may have on it, but it's free. It doesn't cost you anything, okay? All right, folks, till next time, stay safe, God bless, and we'll catch you on another episode of Master the NEC podcast. Till then, take care and be safe.
Thanks for tuning into another electrifying episode of the Master the NEC podcast. We hope you're feeling more powered up and ready to tackle the electrical world with the knowledge and confidence you need to succeed. Remember, in the electrical trade, knowledge is power, and we're here to make sure you stay plugged into the latest insights, tips, and code updates. If you enjoyed today's episode, don't forget to subscribe, leave us a review, and share the podcast with your fellow electricians and industry pros. Until next time, keep your tools sharp, your circuits clear, and your mind focused, because here at the Master the NEC podcast, we're all about sparking your success. Stay safe, stay smart, and keep mastering the trade. From all of us here at Electrical Code Academy, thank you for all your support, and we will see you on the next amazing Master the NEC podcast episode.